So today for my student teaching video, I'm doing titration calculation, and I want to start that off with just the definition of what a titration is. So a titration is a procedure to determine an unknown concentration of a solution, and titration is something that we'll perform in the lab. If you don't know the molarity of a specific substance, you'll do a titration to figure out what the molarity is through calculations. So as our example for our analyte, we're going to be using HCl. You can see here we don't know what the molarity is, but we do know that we're using 20.0 milliliters of that. And HCl is an acid. Down here we have our titrant. Now the analyte is what actually goes in the beaker, and the titrant is what goes in the burette. But for our titrant, sorry, I'm out of breath. Our titrant, we're using sodium hydroxide, NaOH, and we do know the concentration of that is 0.100 moles. And that is a base. So we know that when we add this base to this acid, the point of the titration is to figure out how much of each it takes to neutralize it. So for our indicator here, we're using phenolphthalein because that's what works with those two substances. And this will help us because in the base it'll be pink and it'll be clear in the acid. So you'll add about like 2 or 3 drops to the analyte in the beaker and it'll stay clear. And then it'll let you know over here once you've added enough of the titrant in the burette to the beaker, it'll turn pink. And then you'll know that's your endpoint. So over here we have the actual equation for what we're doing with this titration. So there's an understood 1 right here and right here. So that means there's a 1-to-1 ratio of HCl and sodium hydroxide in here. So when there's 1 mole of one of them, that means that there's the same amount of the other one. And this is balanced. Since it's 1 and 1, it's balanced. And then down here, 2 definitions you should know for titrations are, the first one's endpoint. An endpoint is when all of the acid has been neutralized and the analyte changes color. So that'll be when you add enough of the titrant, it'll turn pink from that clear it was before. You'll know that you've added enough of the base. And then down here, the equivalence point is when equal amounts of moles of titrant and analyte are present in the substance. So that'll be like the exact point where enough is added, sorry. But down here you can see our actual calculations. We're trying to find, or our formula, not what we're trying to find, is moles over liters. So we're starting out with the sodium hydroxide. We know the concentration of that is 0.100 moles, molarity, whatever. And then we don't know, or no, that's the molarity. We don't know the amount of moles that we're using, but we do know the liters. And the liters is just, this is, before you start your titration, you should write down what the initial is, usually be like 0.0 or whatever, you'll fill it all the way up. And then once it's over, you record what the final reading is, you subtract those two, and that gets how much of the titrant you actually used. And it's kind of hard to read here, but it's 48.6 milliliters. But to change that to liters, you just move the decimal place to the left 3 spaces, so it's actually 0.486 liters. And then down here in the second line, I've just kind of rewritten the problem and you just solve for x here. So once you get that all together, you're left with 0.00486 moles of sodium hydroxide that we used in this titration. Now, like I said earlier, it's a 1-to-1 ratio, so we know that if this is the amount of moles of sodium hydroxide we used, we know that the same is for the amount of moles that HCl is present. So down here, I just rewrote it 0.00486 moles of HCl, and then we know that we used 20 milliliters of HCl, so to convert that into liters is 0.020 liters, and then put the moles over liters equals, you solve that, and you get 0.243 moles, and that is your concentration of HCl from your titration.